Welcome everyone to today's presentation titled Compliance Form and ERP Table How-To Presentation. My name is John Souza and I'm an Outreach Account Manager for New Jersey's Clean Energy Program. I handle the outreach for the Clean Energy Program for multiple sectors, including healthcare, data centers, and commercial real estate. And I'm stepping in for today's presentation for Valentina. Our presenter today is Christina LaPearl from Carpman Consulting, who provides day-to-day support for the P4P new construction program. She'll be providing a detailed look into the program compliance form and energy reduction plan tables in order to help our partners submit successful projects. So now I'll hand it over to Christina to begin her portion of the presentation.
Thanks, John. Good afternoon, everyone. Thanks for joining this presentation. As John said, we're going to do a detailed how-to of how to fill out the new compliance form and the ERP tables. Okay, so this is today's agenda. The basic takeaway from this slide is that we have a packed presentation today, and we will be starting with an introduction of what types of tools and workbooks are required for the program documentation. And then we'll move on to demonstrations of different components, requirements, and the different features of the compliance documentation, not compliance, but program participation documentation tools. We'll try to stop around the midpoint for questions, but depending on how we're doing in terms of time, we may end up just addressing questions at the end. So the learning objectives are for the attendees to gain an understanding of the reporting requirements and documentation requirements of the New Jersey Pay-for-Performance new construction program, and then also just in detail how to actually fill out the workbooks that are required for participation in the program. Now, the training touches on the simulation requirements of 90.1, but in general assumes that attendees have maybe just a high-level understanding of these requirements, and the target audience are P4P partners. So the training format is such that there are two interwoven parts of the training. There is a PowerPoint presentation, but then we'll take a break and we'll actually dive into the workbooks. So the demonstration portion where we will dive into the workbooks will take the form of us looking at some design documents within the PowerPoint, discussing the important information that's needed from the design documents, and then showing how to input this information into the compliance form. The training today will focus on the Appendix G path for participation in the program, and we'll briefly cover the BEQ path as well. Okay, so there are two paths to demonstrate above code performance for the P4P new construction program. We have the ASHRAE BEQ as designed path. And in this path, participants create a single model, and there's an EUI, EUI that the actual performance of the proposed design is compared to determine % improvement above code. Then we have the ASHRAE 90.1 2016 Appendix G path. And on our next slide, I'll talk about how that path works at a high level. So with the Appendix G performance-based path, we have two models. Instead of like with the BEQ path, we've got our one proposed design model. For Appendix G, we have two models. We have a model of the proposed design, which is essentially the model as designed. So the different aspects of the design that are within the design documents and specifications are captured in the model, and that's our proposed design model. Then we have our baseline design model, which is created based upon the rules of Appendix G. There are a few elements that are constant across the two models. One is like the simulation tool has to be the same, the weather file has to be the same, you have to use the same utility rates. So that's the basic concept of Appendix G for anyone who's not familiar with it. Okay, so the two pieces of program documentation that we're going to really focus on today is the ERP, the Energy Reduction Plan Workbook. So that's this here. And those we refer to as the ERP tables. And that's where, as a participant, you really enter information about the specific measures. And that's where the actual incentive is calculated. Then we have the compliance form. And the compliance form is there to help establish the necessary modeling inputs, which are established using built-in code lookups and calculators. It also allows importing the results from popular building energy modeling tools, eQuest, Train Trace, Energy Plus, OpenStudio, and it automates the performance calculation. It also has integrated quality control checks so that the submitters are able to QC their models before submitting them. And that can really help to reduce review times and expedite the review process. And so generally when you download these files, you want to just start by reading the instructions tab in the ERP tables, which is going to point you to the compliance form. So then you'll start filling out all of the proposed design information right into the compliance form. And like I said, that really is designed to help modelers establish modeling inputs, but also helps the program understand the different intricacies of your proposed or as-built design. Okay, so we're going to start with going through the compliance form. Okay, so first I'd like to talk about the actual documentation process using the compliance form. So whenever we start a modeling project, we start with the design documents. And as a modeler, you need to enter the parameters of that proposed design into the compliance form. And like I said before, the compliance form will calculate inputs for your proposed design model, and it will auto-populate simulation inputs for your baseline model. It also populates the prescriptive requirements, and I don't know how many of you attended the previous training, but these can be really helpful. So when you're trying to figure out, okay, how can I improve my design? Maybe it's not achieving the level of performance that you're hoping for. By having the prescriptive requirements right there, you're able to see perhaps some areas where the design can be improved. So then that information is input into the building energy modeling tool. And of course, there's often back and forth because there are certain inputs, especially for the baseline model, that require some preliminary information from the model. For an example, you need preliminary like HVAC system sizing in order to figure out what your baseline system efficient cooling or heating system efficiency will be. Okay. So this is a high-level overview of the compliance form organization. Each box here represents a tab in the compliance form. So the sections or tabs that you see outlined on this slide will be covered in today's training. So we're going to cover some general tabs. We're going to cover envelope lighting, HVAC, and then we're going to cover the compliance calculations and quality control tabs. All right, we're going to start with a discussion of some of the general features and the general layout. So we're going to touch on the tabs outlined in red that you see here. So first, we have the basic structure of the compliance form. So the tab colors vary depending upon the type of tab input required. So the blue tab, that color blue you see here, those tabs do not require inputs from the design documents or from model output reports. They're informative tabs. Then the beige color tabs are tabs that require inputs either from the modeler or the design team. And these tabs are the ones that are related to the baseline and proposed models. For example, these are your HVAC, your lighting, your envelope tabs. Bright green tabs are for importing model output reports and tabs that perform the actual performance, or also known as compliance calculations. And the orangey colored tabs are tabs that pertain to quality control. So there's a submittal checklist tab to make sure that you have everything required in your submittal package. And then there are tabs with actual QC checks. All right, so I want to show you this first little productivity tip. So the default for the compliance form is to not show the headings or the formula bar on each of the tabs in Excel. And so you can see here that like you don't see like A, B, C, D across here. And then you also don't see the formula bar here. Now, I know this can annoy the heck out of some people, and you might want to see, you know, what cell you're clicking on, or you might want to see the formula bar so you can see the formula. So this can easily be changed. So all you have to do is click on View, and then you just check either the formula bar or the headings boxes here, and you can click both or one or the other, whatever you like. And then as you can see, it'll show you the headings, and then it'll show you the formula bar. Another productivity tip has to do with help. The compliance form put most of the helpful text into these pop-ups in order not to crowd the interface and make it easier to work with and read. So throughout the compliance form, there are these help buttons, and they have a question mark, a blue question mark. So when you click on these help buttons, a dialog box, such as the one you see here, will pop up, and you can scroll through, and the scroll bar is activated by actually clicking in the box. So you can scroll through the text and then close it when you're done. If there's a link or something in here, like to a website, you can actually select the text and copy the link so that you can easily navigate to whatever website is being referenced. Okay, so this slide is to show the default tab layout. So each tab in the compliance form has a table of contents, which shows all of the sections and tables on the particular tab. That's what you see right here. And this is so you can make sure you don't miss anything, and so that you understand the full contents of what is on the tab. These are also hyperlinks, so you can easily jump to different tables within each tab. There is a adjust column widths and row heights button. Now, this is to allow users to adjust column widths and row heights while the workbook is still protected. That can be a bit of a funky feature within Excel. That's why we've placed a button here, because sometimes it works, sometimes it doesn't. It's a bit of a finicky feature. So when you press this button, you can be sure that you'll be able to adjust the column widths and row heights. We all know how frustrating it is when you can't see the contents of a cell, so you're able to adjust them. This here is the return to dashboard hyperlink. So this will take you straight to the dashboard tab. We'll discuss the dashboard tab on the next slide. And then right here, I just wanted to point out that each tab and each section and each table has notes sections associated with them. So I just want to emphasize that these are great places to put notes to the reviewer about anything special about your project. If it deviates from something that populated in the compliance form, or you didn't feel you could quite capture everything in the table, this is where to put your notes. And these can help reduce review iterations and comments, because the reviewer will have their question answered through the notes potentially. All right, so this is what the dashboard tab looks like. And the function of this tab, there are a number of functions actually. One is to allow easy navigation to all the tabs in the compliance form. So if you see all the hyperlinks here, these are all the tabs in the compliance form. So as you saw on the previous slide, each tab has a return to dashboard hyperlink. So you can come to the dashboard and then you can jump to other tabs. So this makes it so you don't have to scroll through a bunch of tabs. You can just jump to the dashboard and then jump to where you want to go. This also shows the compliance path. So in this case, because this is a P4P version of the compliance form, we're always going to see a P4P new construction ASHRAE 90.1, and it'll either say 2016 or 2013 right there. Then we have this section here, and this is to help with the QC process of the compliance form and the submittal in general. So basically what this is it's a place for the design professional to mark and basically quote unquote sign off that they've reviewed each of the applicable tabs. And a particular design professional can be identified and assigned to the relevant tabs. So the intent is that the design professional basically signs off that they've reviewed the tab and that they agree that the inputs are consistent with the actual design and design documents. And then they would put a date once they've signed off. These dates can also be used and are also useful for tracking when changes have been made. Sometimes it can get a little confusing. Let's say you entered data on on some of the envelope tabs back in April, and then a new set of drawings comes out in July, and then you don't look at it till November, and you're like, did I update that? I don't remember. So you can track that here when a tab was last updated. There's also the modeler sign off, and this is for the modeler to review the tab and basically sign off that the modeling inputs that have been calculated on the tab are consistent with what was actually modeled. So this is just a great tool for providing QC for your project. Okay, so now we're going to go to the compliance form itself and take a look at some of these tabs within the compliance form. So this here is the tab that you are going to start with when you open the compliance form. This is the New Jersey Pay for Performance New Construction Programs Special Custom tab. And I don't know if I said this before, but the compliance form the creation of it was funded by the Department of Energy and PNNL, and so it's used nationwide. And the version we're looking at here is specific. It has the general features of the national version, but it has this tab that is unique to the P4P program. So you're going to start by entering and filling out your project specific information on this P4P tab. And so you really need to fill out this tab completely. And for some of you who have participated in this program for a long time, you'll recognize these inputs. These used to be in the ERP. And what we've tried to do is confine the inputs to the compliance form so that they can be imported into the ERP. So there's not a lot of back and forth between the two files. Then we have the instructions tab. I'm going to go pretty quickly through these tabs. You can read through them, but instructions tab provides instructions, step-by-step instructions, productivity tips, for using the form, there's the color legend. If you're ever like, what the heck does this mean? You can come here to see the meaning. If you're unsure about the meaning of an acronym or an abbreviation, that's also here. And then links to reference documents that are referenced throughout the compliance form are also here. Okay, so next we have the dashboard, which we already went over, but I'll just show you a quick demonstration of how the hyperlinks work. So next we're going to talk about the contact information tab. So I'm just going to jump there. So I go straight to the contact information tab. So this has been customized for P4P. So we have our sample project information, our sample project contacts, and then just some information about the energy model or qualifications. So next I want to go to the general information tab. So I'm going to return to the dashboard, and then I'm going to go to general information. So this tab contains basic information regarding the energy model and the building in general. Details such as the climate zone, the simulation tool used. So we have a drop down of a number of options. The majority of the popular tools are listed here. Your weather file name. So for P4P, it's always going to, you always want it to say ASHRAE 90.1 2016 Appendix G, where I'm clicking here. And then it should always say above code program. So this is for on the compliance path row. So it's always ASHRAE 90.1 2016. It's always above code performance. Here, though, you have some options. And you're either going to choose P4P NC ASHRAE 90.1 2016, which is, if you're starting a compliance form now, that's likely what you're going to pick. But if for some reason your baseline code is 2013, you can also choose that. And what will happen is the compliance form, all of the prescriptive requirements that populate, they will be based on 2016, but the building performance factors will change to reflect 2013 for the P4P program. So that's the difference there. Okay, so this is, I'll go through this quickly. I think a lot of attendees are familiar with this type of information. You define your building areas in table 1 on this tab. And you, if it's, this is a multifamily with retail example, so you characterize your dwelling units, the number, the area, the quantity, and then down towards the bottom, if there's any yet to be designed areas of the building, if it's a renovation, you'll need to indicate that in this section, because there are special rules for these scenarios. So the reviewer and the team in general that are working on the project need to understand if any of these scenarios are applicable. Okay, and then we have, lastly, in terms of the general tab, we have energy sources. And this is where you enter all purchased energy sources that are part of the project. So site to source ratios, greenhouse gas emission factors. So the program has the numbers that should be used for these. For the site to source ratios, these will auto-populate with the correct value, so you don't need to change those. But you will, the main takeaway here is to enter all of the energy sources in the project and the utility rate type. And what will happen is after you enter your utility rate type, other tables will automatically unhide where you can enter the details regarding your particular rate structure that you're using. So in this case, we've got our example, we have fixed rates per unit of consumption, and we've characterized those structures right here in table 2. And please note that based on your modeled utility rates, the information in the compliance form will be imported into the ERP, and those rates will automatically go into the ERP. So you're not going to be entering this again in the ERP, in case you were worried. Okay, so let's go back to the PowerPoint and move along with the next section, which is lighting. So right now we're going to start with lighting. We're going to do lighting, envelope, HVAC, and a few other sections. And what we're going to talk about is we're going to look at the information related to that particular component in the design documents and specs. And then we're going to talk about what type of information is available, and then what are the relevant compliance form and simulation tool inputs. And we're going to do some examples. So let's start with lighting. So when you start dealing with lighting for your model, you don't just look at the design documents and directly enter lighting information into the simulation tool. There are intermediary calculations that need to be performed. So from the design docs, as you see here, you got your lighting plans, your schedules, your specs, and in the BEM tool, Building Energy Modeling Tool, BEM tool, we've got the power, lighting power for each HVAC zone. And then we've got the schedules for those zones. So in a little bit more detail, in the design documents, we've got our lighting schedules with wattages for each fixture based on the specified bulb and ballast or the total integrated fixture. We've got our lighting plans, which show you the number and location of the fixtures. They also generally show you the proposed lighting controls for each space. So the design documents show us for each space. Then we also have the specifications, which I think sometimes are ignored, but they're very important because they often clarify the different control sequences. So in the case of lighting, if we don't know, if we look at the design docs and we say, okay, I see the symbol, it says this, but what does that mean? Sometimes it's clarified in the specs. So they can be very important. So in terms of the BEM tool inputs for the proposed design, we've got to calculate from this information in the design docs the lighting wattage and any potential lighting schedule adjustment credits for each HVAC zone, not space, not architectural space, each HVAC zone. And that has to be based on the maximum rated wattage of those specified lighting fixtures. Then for the baseline design model, we need to determine the lighting wattage for each HVAC zone again. And this will be based on the 90.1 lighting power allowance in Appendix G. And that will be determined based on the type of spaces that make up the HVAC zone. So here's our example to illustrate this process. So for lighting, prior to entering your lighting information in the compliance form, generally you're going to want to create the building geometry in the energy model. And this is so that you have the names of the different thermal zones from the model. So right now we're going to talk about this example here from a set of design documents. And this is one HVAC zone here that's not highlighted, but that has a red line around it. And so it's a single HVAC zone because there's a thermostat in one of these spaces that controls a unit that serves both of these spaces. And so it makes up one HVAC zone. However, there are two different space types that make up this zone. So we've got storage, and then we've got a metal shop. Okay, so those are two different space types. So from our model, you can see this HVAC zone here in the model, and this is the name of that HVAC zone from our model. And we've taken this from our lighting plan. Our next step, so now I'm going to focus on one of those spaces in terms of how you'd go about gathering the information for the compliance form. So as discussed before, we have our lighting schedule where we can see the wattages of all of the fixtures on our lighting plans. So for here, we're looking at our lighting plan, and we can see we've got these 6, 1, 2, 3, 4, 5, 6 B1 fixtures. And we can see from our lighting plan, because this is a very nice lighting plan, that tells us that the space is 471 square feet. So then we go to our lighting schedule and we see, okay, B1 says it's 43.2 watts. And you know what, I'm going to double check in the fixture spec that is the maximum fixture wattage, because I know that's required by the program in Appendix G. And so you see that, okay, the input wattage of this fixture is in fact 43.2. So we now know we have 6 B1 43.2 watt fixtures in a space that is 471 square feet. And that is our project storage 101G. So then our next step for this particular space is to determine what kind of lighting controls are associated with this space. So we check out our lighting plan and we see, okay, I've got these two, looks like occupancy sensors, and then this VCS, okay, and they're all wired together, so they're all controlled together. What is this? So then you ask yourself, what is this VCS? Okay, I go to my lighting symbols key, and it tells me that it's a vacancy sensor control switch. And then I confirm, okay, these are occupancy sensors shown on the ceiling. So at this point, you could make some assumptions about how the vacancy sensor control switch works, but the best thing to do next is to check the specs to fully understand what is the nature of this control switch. How does it work? And we looked this up in our specifications for this example, and it tells us that the lights are manually turned on for this vacancy sensor, and that the lights are turned off automatically with a time delay. And there's an adjustable range from 1 to 30 minutes. So great, we've got the full picture here. It's a vacancy switch. The occupant will come in, they'll turn it on, and after a set amount of time, if no one's in the room, no one's perceived to be in the room, the lights will shut off. All right, so controls in the compliance form are captured as they are defined in section 9 and table 9.6.1. So I'm sure this table looks very familiar to everybody in the trading today. So I just want to illustrate which ones of these control types are applicable for this example. So let's talk through that. What you see boxed in red, that's our relevant storage room in this table. So we can first see that local controls are required. Well, that's easy. There's a single control that controls the fixtures in the room. So we know that's all good. So next, we've got these two ADD1, ADD1. So what the ADD1s means is that they're required to have either of these two control types. So either restricted to manual on or restricted to partial manual on. Well, we talked about how the specs told us that the occupant has to come in and manually turn on the lights. So we know we're good there and that we have a restricted to manual on sensor. Then we can see that daylighting controls are both required, but there are no windows or skylights in our space. So those are both NA. And then lastly, automatic full off is required. And this check came in a little quick, but you can see that because our fixtures turn off after a set amount of time, which per 90.1 should be at 20 minutes, that requirement is met. So this tells us which of these are applicable to the project. And so next we're going to go into how to capture this in the compliance form. Okay, so let's go to the lighting tabs. So I'll start with lighting space types, this tab. So when you do your lighting, you'll start on the lighting space types tab. And in table 2, you start by defining all of the space types associated with the project. The reason this is here is to eliminate excessively long list boxes on the other tabs. I'm sure we're all familiar with when you click on a list box and it's like 20 pages long, it's hard to use. So this will help to limit the options on other tabs down the line. Next you will define the thermal blocks, or the also known as HVAC zones, from your model. So basically you just copy these from the simulation tool right here, and it's very easy to add a bunch of rows. And as you can see, this was the zone that I showed you on that slide that's relevant here. So you can characterize all your HVAC zones right in table 3. And this again is for the next tab. And what it does is it creates a list box of HVAC zones from the model that you can choose from. And it's not so much so that you can pick from the list box, but it's to make sure you don't make a typo. Because what the compliance form will do is it will quantify the lighting power densities by HVAC zone, which makes it very easy to put into the model and makes it very easy to QC your model. Okay, so next we have our interior lighting counts tab, and just the basic, structure of this tab. It's similar to the old performance path calculator, but you define your fixture information here, and then you enter the lighting counts and controls row by row for each space in the design docs. Okay. So I'll start by showing you some productivity tips for this tab. One is that if you double click on a row, you can mark it and then you can unmark it. So this can help you, like if there are rows that you want to go back and check later that you're not quite finished with, you can highlight them. You press Control-Shift-P to add a row, which is similar to the performance path calculator. You press Control-Shift-M to freeze panes, which makes it so much easier to navigate, and then just do it again to unfreeze them. And I want to show you another feature that I think is nice, this filter feature. This actually is one feature in the compliance form that takes a second to run. Everything else is pretty fluid. That one takes a second just because it has to do a loop, but it gives you this nice feature of being able to filter the down the rows. So if you're saying, you know what, something's wrong here, and I need to figure out what's going on. I just want to look at the corridors. Well, then you can just see the corridors. So it's just another way of working with your data to make it easier. And then turn the filter off. All right, so let's go over our example here. I'm going to freeze panes to make it easier here. Control-Shift-M. And so I'm going to scroll down. This is our example project to the two spaces that we were looking at in the PowerPoint. So remember how I mentioned to you all that we had two spaces in one HVAC zone, which you can see right here. Well, as you can see, I've included these two spaces and then I've assigned them the same thermal block. And this will allow the LPDs, lighting power densities, to be calculated for each thermal block. In the past, I think oftentimes some users would choose the predominant space type for a thermal block and enter that, but this adds more granularity, which is compliant with Appendix G. Okay, so our zoomed in detailed example was this storage room that you can see here on this row. We've entered the space name from the architectural drawing. We've selected our thermal block, also known as HVAC zone. We've entered the location in the plans where we've gathered this information. We've characterized the space. We've entered the area that we saw in the PowerPoint. And then we've defined the fixture up here associated with that space, which, as you recall, was fixture B1. So let's take a look. So we had 6 B1 fixtures. So we've defined our B1 43.2 watt fixture. You can see here we have 6 of them. So we've entered that. Pretty nice and easy. And then we go and we do this for each space in the design documents. We go across and it auto calculates the proposed design and the baseline design lighting power densities. It also populates the prescriptive requirement, again, so we can identify areas for improvement. And then we need to just capture the controls associated with the space. And that's done in this section here. And so this right here is where automatic daylighting controls are captured. So we have nothing there. So 0 watts controlled, NA, because we have no windows, so daylighting controls are not applicable. But then here, as you can see, this is the automatic occupancy sensor section. We enter the total controlled lighting wattage, which in this example is the full wattage of the space. And then we just select yes or no to all of these different options that were shown in the table in 90.1. So it makes it quite easier. It's just yes, no, and they're defined that they follow these particular types of controls. So in our example here, we've got yes to manual on, yes to full off. And the nice thing is that the compliance form will tell you when a control is required by showing this red outline. So if I were to put no here, it would still have the outline, which indicates to me you're not meeting mandatory requirements. So all the red goes away once you've selected yes, no, and you're consistent with the mandatory requirements. And then the credit per Appendix G that you can apply to the proposed modeled schedule for that space populates here. And also here, just as a reference, it also shows the requirements from the standard for that particular space for lighting controls. And then finally, we've got an additional notes column. And for this example, the submitter just indicated there were no windows so that it was clear why daylighting controls were not applicable. So that is entering the details of interior lighting. Lastly, for this lighting demo, I just want to show you the interior lighting model inputs tab, because this tab I think can be very helpful in that it provides you the lighting power densities for the baseline proposed and also the prescriptive by space. And there's this freeze panes feature, so you can easily scroll across and still see the spaces because the tables can be a little wide. So we've implemented this feature for the tables so that they're easy to navigate. It also provides you the weighted average occupancy sensor credit you can apply to the schedules in the proposed. So that's calculated in this table as well. The same table 2, or not the same table, but the same information that you entered on the lighting counts tab feeds into populating the lighting power density and lighting power for the proposed, baseline, and prescriptive by thermal block. So sometimes it's just easier to enter your proposed and baseline lighting power densities for each thermal block in your model, as well as applying the credits to the schedules. So that is all calculated for you here. It makes it really easy to QC your model as well. Okay, so I think we are back now to the PowerPoint to move on to building envelope. Before moving on to envelope, I'm just going to touch on some common lighting mistakes to try and look out for when you're creating your submissions. The first one I touched on briefly, people will often choose the dominant space type associated with a modeled HVAC zone and use that to determine the baseline. The baseline should be determined based on all the different space types and their areas that make up that particular HVAC zone. Often there's a failure to model proposed design controls, especially daylighting. And I think sometimes this can occur because the controls aren't completely clear on the design drawings. So often you'll need to request specifications for how the controls work exactly from your design team. Also, sometimes it can be finicky to enter them. We try to make it easy for you to go through your design and make sure you meet mandatory controls and to easily enter them in the compliance form. A lack of accounting for lighting is unspecified. Yeah, that's sort of a special case, so I'm not going to get into a lot of detail now, but that comes into play for dwelling units, hotel rooms, places where lighting, hardwired lighting, is to be supplemented with plug-in receptacle lighting. And then lastly, not modeling the maximum fixture wattage and failure to include all the components of a fixture: lamps, ballast, drivers, transformers. Where we most often see this nowadays, now that LEDs are king, there'll be a fixture that the design documents have it such that it's supposed to have an 8-watt LED bulb, but the actual fixture itself is rated for 60 watts. So that's often where we see that mistake made, because in that case, per Appendix G, 60 watts should be modeled. All right, moving right along to the building envelope section, where we will go over the tabs shown outlined in red here. All right, so what's relevant to envelope in the design docs? We've got our construction assembly schedules, our elevations, our window and door schedules. And envelope is quite complicated in that information needs to be taken from the design docs, and you need to model those assemblies and their thermal properties accurately. You need to capture the window and door thermal properties. You need to capture all the different areas of fenestration, of the different assembly types. So there's quite a bit of sort of intermediary steps from going from the design docs to the actual BEM tool. So in the design documents, you'll be looking for those thermal properties of the opaque assembly. You'll look at each layer. What are the thermal properties of each layer? For windows and doors, you'll want to get the actual NFRC ratings for the thermal properties. And then you'll need to understand and quantify the window and door locations and their areas from the design documents, so that you can take that information and develop the thermal properties of each opaque assembly using Appendix A to account for thermal bridging, so that you can put that information into the BEM tool. So basically, you'll also need to use the NFRC ratings, as I said before, to determine window and door U values, which will then go into the BEM tool. And then all of the different areas of each you'll need to capture in the BEM tool. And for the baseline, these are items that I discussed for the proposed design. They will be determined from Appendix G and the associated tables. So for an example, there's a table in Appendix G that tells you what window to wall ratio to model in the baseline, depending on your building type. And the compliance form has built-in lookups for determining these baseline inputs. So it really helps with the calculations for the proposed, so that you can go from here to these inputs, and then there's lookups for the baseline. So we'll do an example again, going from design docs to the compliance form. So we've got two opaque assembly examples here. We've got an exterior wall. And if we look at our layers and the description for each layer, we can see that we have a wall assembly that contains R19 cavity insulation and R8 continuous insulation, that's continuous layer, and that we've got 6-inch metal studs, and nice, tells us right there, and that they're 16-inch on center. So this information is crucial for developing the thermal properties of this assembly, which we will model in the proposed design. We've got our roof assembly, which is a bit simpler. It is insulation entirely above deck. It tells us that our continuous insulation is R39. And then we have a waterproof membrane and a vapor retarder, some other layers that don't significantly affect the thermal properties of the assembly. And then our reflectance and emittance values, which also are captured in the energy model. So we've got that information. Next, what we'll want to understand is, okay, so what is the area for each orientation of the windows? And what is the area of each different type of assembly? And this particular set of design documents capture that for us in the design documents themselves for each orientation. And so in this example here, I didn't show the assembly, but this particular building has both the assembly that I just showed you, this one, and then there's also a brick slab edge assembly. So the design documents quantify these nicely for us, so we know the window area, we know the area of each assembly type by orientation. These can also come out of the simulation tool. Often that can be easier. Okay, so now I will show you how this information is captured in the compliance form. So for envelope, we start on the proposed envelope assemblies tab. And in table 1, here on this tab, you enter all the information about the proposed assemblies. Table 2, and again, you can see these in the table of contents at the top. Table 2 is for entering and characterizing the fenestration in the project. So I'm going to use the freeze panes feature to help show our example. So we've got, our example was the roof and the above grade wall. So let's start with the roof and how the information was entered in the compliance form for the roof. So our modeled construction name is roof. And I just want to show you, like, there are certain cells that will fill red if you don't enter information. And these, I mean, it's important to fill in all the cells, but the ones that show in red are crucial for things to calculate correctly in the compliance form. So if you're ever like, why isn't this calculating? It's not working, look out for a red filled cell. So we start with roof, we choose the surface type. Now note, these are all drop downs and they're based on the options in 90.1, specifically Appendix A. So we've got our roof type, which is insulation entirely above deck. Sometimes there's a qualifier on that under this detailed description. Like you can see for our above grade wall example, we gave it a construction name, selected above grade wall, it's steel framed, but then we had to choose whether it's 16-inch on center, 24-inch on center. We had to choose the detailed description. So that's what goes in this column here. So for the roof, we have 0 cavity insulation, and we've got R39 continuous, so we enter that. And then the compliance form will calculate the Appendix A U value, or F factor, C factor, whatever's applicable to the particular surface type for you. Now there's a few types that aren't supported, but for the most part, they're supported. So that is hopefully very helpful. It's very common that comments come up regarding how the assembly U factor or C factor was determined. And so the goal is that this automatic calculation and lookup is helpful for the submitters in determining that U value. But sometimes, right, like Appendix A doesn't necessarily capture everything in your assembly. You might have additional layers that add to the thermal resistance of the assembly. So there are additional columns for describing that information. So that's what you would do here. And then in this column, you would enter the actual modeled U, C, or F factor if it's different from Appendix A. There's more opportunity to explain the reasons for what you modeled. And then there are just a few questions and requests for descriptions having to do with uninsulated assemblies, similar assemblies. These are kind of nitty-gritty details in Appendix G, but you can capture that information here. And of course, as always, you need to enter the plans and specs where the information comes from. This is sometimes skipped, but it's not recommended because it really helps to expedite the review process to have this information, because then we don't need to ask for it. So if it's there, we can check it, and then we can really move things along much more quickly rather than going back and forth. So very similar process for our above grade wall. We entered the R19 for cavity insulation, R8.5 for the continuous. It gave us our U value from the Appendix A table, and it tells us which table is relevant. So we've entered that information for our example assemblies. So then I can always unfreeze panes by clicking it again. So I've unfroze my panes, whatever. So then we've got our proposed fenestration. Very similar to above, you just capture your fenestration types and thermal properties, and they should be based on the NFRC testing for that fenestration. All right, so after you've characterized and defined your fenestration, all your unique fenestration and all your unique assemblies, then you're going to move on to the envelope areas tab. And in table 1, you just capture all of the opaque surfaces. So all of your opaque constructions and assemblies that you defined on the previous tab, and you'll have a list box to grab them based on the names you gave them on the previous tab. And you'll basically capture them by building area type, orientation, space conditioning category, and whether it's new, existing to remain. A lot of the time it's just new or maybe retrofitted, but you capture that information here. And as you can see, the baseline assembly UFC factors auto-populated, so you can put them into the model. And throughout the compliance form, you'll see these different colors. You'll see this peach color, this purplish color, and this white. So peach requires user input, purple auto-populates but can be overridden, and then white auto-populates but is stagnant. It can't be overridden. So just to show you an example of one of the pop-ups, I clicked on that and it came up with some help for me on that building area topic. So you do the same thing for windows. So you capture in table 2, you capture the window area by window type, building area, orientation, building envelope conditioning category, similar to the old performance path calculator. And once again, the thermal properties for the baseline will auto-populate for you to put into the model, as well as the prescriptive requirements, so that you can see, oh, you know what, we're not doing so great. There's an opportunity for us to get additional savings. We're not even meeting the prescriptive. So that's why that is there to help you. So you then press this calculate window to wall ratio button, and it generates tables 3, 4, and 5 for you. And tables 3, 4, and 5 are summary tables that populate the proposed design and baseline design fenestration areas. So these will take the required baseline window to wall ratio from Appendix G. So for an example, off the top of my head, let's say retail, I don't know what it needs to be off the top of my head, but let's say retail had to be 11% window to wall ratio. It would take your proposed entries and adjust them such that, according to the rules of Appendix G, such that it establishes your modeling input for the baseline for each orientation and building area type and surface type. So these are summary tables. This table 5 is to help QC the model, because this is how a lot of models report these variables. So you can compare your modeling output reports with the values in this table just to make sure you're doing it right. And I just want to show you, in some instances, like I said, these purplish cells, they can be overridden. So if you do override a purplish cell, it'll turn this bold orange. And that's one, to help you remember that you overrode it, and for reviewers to see you overrode something. So if you override something, throw a note in the notes section explaining why it was overridden if it's not obvious. And in the case of window to wall ratio, if it's an existing building and the window to wall ratio is changing between existing conditions and the proposed, you might need to make some overrides, because this won't capture that scenario. But other than that, it should capture most scenarios accurately. And then I'm briefly going to touch on the other tables. So table 6 on this tab, you can capture shading. And again, it's pretty simple in that you can just check off what's applicable, and it will tell you how it should be modeled in the baseline and proposed. And as always, indicate plans and specs where that information is coming from. And that's not only good for the reviewer, but it helps, as a modeler, I know that helps me stay organized. So I'm like, wait, where did I get that? Is that accurate? Let me recheck that. Or if a design updates, you know exactly where to go back and check if something's changed. So it's very helpful. And then the last section on this table, you just select whether the baseline building performance was generated by simulating the building with its actual orientation. And then again, after rotating the building 90, 180, and 270 degrees. There are some exceptions where that's not needed. So if that's the case, you would click the appropriate radio button here, and then this would unhatch, and you would enter your justification for doing that. And lastly, for envelope, we have infiltration. So table 1 and 2 on this tab, they auto-populate based on the information you've entered on envelope areas. And this is a helpful tab because Appendix G, air leakage is prescribed at 75 pascals, a 75 pascal pressure differential. And most simulation tools actually require entering infiltration at normal pressure conditions. So this is where the compliance form converts to normal pressure conditions. And it actually offers a variety of units that the user can toggle between. You can pick different ones from this dropdown, and it'll automatically update, because your simulation tool might require, for an example, air leakage to be entered by total building area or gross floor area. It differs from tool to tool. So that's what this tab is all about. Okay, so back to the PowerPoint. All right, so some common envelope mistakes. I think for today, I'm going to skip this. We hope to do another training about that focuses on common mistakes. So I think we'll get into more of these nitty-gritty details during that training, but the slides will be emailed to everyone. So feel free to take a look at this slide after to read through some of the common mistakes so that you can avoid them in your projects. Okay, so next we have HVAC, and we'll be focusing on the tabs you see outlined in red here on this particular slide. Okay, so with HVAC is also quite complex in that in the design docs, we've got mechanical schedules, we've got riser diagrams, we've got plans for piping, ductwork, etc. Then the BEM tool, you need to characterize system types, sizing, zoning, controls, efficiency. There are many, many parameters, and they need to be organized. So what specifically? So in the design documents, the schedules show us the capacities, the efficiencies, the components, for an example, CO2 sensors, things like that. The schedules can sometimes also show us control sequences, or those can be elsewhere. They show us make and model numbers for the equipment. The HVAC ducting and piping plans and riser diagrams help us to determine the HVAC zoning. And sometimes they'll show CFMs to help us understand the airflows associated with each of these zones and the ventilation system. So for the proposed design, we need to capture the HVAC zoning in the BEM tool. We need to capture the equipment type. We need to capture the heating, cooling, airflow, all of those different capacities. We need to capture the efficiency, including the part load performance curves. We need to capture fan power, which needs to be calculated. We need to capture pumping power. We need to capture the control sequence, and all this needs to be done for each thermal zone. So that typically requires quite a bit of organization and some calculations between those design documents and the model. And for the baseline, the HVAC zoning is the same as the proposed, but the HVAC equipment type is determined from Appendix G. Same with the capacity, efficiency, fan power, pumping power, and control sequences. Those are all determined from the rules in Appendix G. So quite a complicated process. And so here's our example. So the building we've been discussing is multifamily with 3 floors of retail, which has been designed. The retail has been designed. And so prior to this stage of entering the information we're about to enter in the compliance form for our example, you would have previously determined the HVAC zones. But now we're at the stage of entering the detailed equipment information. So what's been highlighted here are the crucial pieces of information for the model and for the compliance form. And the compliance form will take this information and calculate some model inputs for us. And so we've got 6 packaged rooftop units, and we've got the CFM, we've got the outside air CFM, we've got the brake horsepower for the supply fan motor, we've got our gas furnace output capacity, we've got our thermal efficiency for the gas furnace, we've got the fact that it's a gas furnace and not a hot water coil or something else, so that tells us our system type. For cooling, we've got our total capacity, and then we could tell by the fact there's a condenser, leaving air temperatures, compressor, that this is a DX system type. Then we've got our cooling efficiencies here, which are crucial. And then we've got our filter types. So Appendix G may allow us additional fan power in the baseline design if we have certain high filters with that result in a high pressure drop. And then in the notes, often there's some really important information. There's some information often about how the units operate, also information about the types of controls and features that the units are equipped with. So this tells us it's variable volume control, that there's a constant supply air temperature, and then it tells us that there's a differential enthalpy economizer with a high limit set point of 75. And these all came off drawing number M-400. So this is the important information that we're going to want to enter into our compliance form to get our model inputs. All right, so let's move to the compliance form to talk about this. All right, so I just want to first give you a general overview regarding how HVAC is captured in the compliance form. So there are 2 tabs. We've got our proposed HVAC tab and our baseline HVAC tab. This is similar to the way the performance path calculator was set up. However, these tables are much different than the way it was captured in the performance path calculator. So you're going to enter your proposed HVAC information. And if we take a look at the table of contents at the top, both of these tabs, they actually have very similar information. So for the proposed and baseline, you're going to enter information about your HVAC air side system type, the capacity, the efficiency. You're going to capture your fan system design, fan power. You're going to enter cooling plan information, control information. You're going to enter information about loops. You're going to also enter any pressure drop adjustments. So both of these tabs, the takeaway with that is both of these tabs have analogous information, just one is for the proposed design and the other is for the baseline. Now, if you look at the proposed tab, everything is that peach color. Yeah, there's some purple, but it's mostly peach because how would the compliance form know what your design parameters are? You need to enter that. But for the baseline, most entries auto-populate, so you see a lot of white and purple, especially if we go down to, oh, it's not applicable. So if something's not applicable, it's hidden. So that's why I got that message there. But yeah, so if we like scroll through the tables, a lot of this is purple. So this will help you identify like what controls need to be modeled in the baseline. And sometimes there's an exception that applies. That's why you see a lot of purple, so that you can capture those exceptions. So here's the heating plant table. And look, almost everything auto-populates except for the total input capacity for the heating plant. And then this is our loop table where all the different loops in the baseline are captured. And this will auto-populate. And the only thing you really need to enter is the GPM. So again, it's really designed to help you. And on the baseline tab, under each table, there's a summary table that shows you a comparison of the proposed design to the baseline. And this is to help reviewers and submitters QC their model and their entries. Because if you see something that's very, very different between the baseline and proposed, it doesn't necessarily mean something is wrong, but it's an area to investigate to see if maybe an error was made or something. All right, so let's talk about our example. So our example is the retail system. So I'm going to use the freeze pane so we can feature so that we can just look at that row here. So you would enter the modeled system name, the name on the drawing, and of course, as always, the drawing plan spec information, the area served, quantity, and then the equipment type. And these are all drop downs to make it easier. And so you'd capture the system type related and capacity information in this table. And then you'd enter the specified efficiencies and then the minimum efficiencies per section 6 would auto-populate, and you get green outlining on your proposed efficiencies, which are here if you're doing better than or meeting or doing better than the minimum efficiencies. You get a red outline if you're doing worse, and you're not allowed to do worse because it's required, mandatory requirement, so you'd have to fix that. So yeah, this is similar to the performance path calculator, similar information, but it's in this table format. So you enter that, and then you just go down each table, and the tables auto-populate, the names of the systems auto-populate in each table based on the table 1. So then for our retail system, we would go to the fan power and efficiency table, and we would enter the total supply CFM. And remember, the capacity, the total supply CFM, these are totals. So let me just illustrate this here. So in the PowerPoint, we saw we have 6 rooftop units, and they have 2,417 CFM each. So that means in the compliance form, our total supply CFM is going to be the 2,417 times 6. So that's what gets entered here, the total. So it would be the total brake horsepower. So it's 1.67 times 6. Okay, so your total brake horsepower, your motor efficiency, and would be entered here, and kW auto-populates. So you go down each of the tables. If there are any pressure drop adjustments associated with the system, you can enter in this table. Sometimes this will be inapplicable. And then we've got our table 4, which defines our controls. So for our retail system, we have the differential enthalpy control that we saw in our notes section right here. So that's captured. And what will auto-populate for you is whether section 6 requires the particular control type. And so it'll populate yes or no. If it populates yes and you don't have it and it's a mandatory requirement, then you can select which exception applies. So to make it really transparent and easy to really try and expedite the review process. So if you have demand control, ventilation, and exhaust air energy recovery, that's all captured in table 4. And then if you have any loops in your project, there's a loop table. Cooling plant is captured on this tab as well if you have a cooling plant. So heating plants, it's organized to make it easy to read and understand what you're entering. And then lastly, there is a section on the proposed HVAC tab where if you have any measures that you don't feel have been captured adequately in the other tables, you can explain them here so that we understand the full scope of the project. So that's HVAC. So once you enter your proposed information, you would move on to the baseline tab, and you would then begin entering your baseline systems with many things just auto-populating for you. All right, so that is HVAC in a nutshell. And then some common mistakes. I'll just touch on this quickly because we still have not a huge amount, but we've got some more things to get to. So I'll just pick the most common one here. What's the most common one? I would say modeling the incorrect baseline system types. So the compliance form tries to help with this by basically there are drop downs for you to choose the baseline system. And these are limited a little bit depending on the climate zone, number of floors, stuff like that, building type. So there is some limiting of this list to avoid that common mistake. Read through the others on your own time if you have a chance. So next, we're going to get to the simulation outputs, compliance calculations, and QC tabs. All right, so many of you who have participated in the program are familiar with the results from eQuest or results from trace tabs. So this is pretty much analogous to that, except now the compliance form supports more tools than previously. So the supported tools are listed on this tab, but the vendors for the different tools were consulted and they were worked with in order to develop tabs so that the common output reports could be copy and pasted into the compliance form and basically essentially importing the modeling results into the compliance form. So then that results from eQuest or Trace or Energy Plus, whatever tool you're using, when you've copy and pasted those reports onto the results from tab, the compliance calculations tab will calculate your performance. And this, as I said earlier, this tool has been created specifically for the P4P program, this version of the compliance form. So it includes the P4P program building performance factors. So the cost and source energy performance that you see in table 7 is your performance for the project. So it's not like with the performance path calculator where it might show different results. You should see the same results in both the ERP and in the compliance form. So this will help let you know where you're at. Then there's this new tab. It's called Energy Performance Summary. And I love this tab because it allows you to basically compare the results of the model to different benchmarks. So DOE, PNNL created some prototype models that are representative buildings for the different versions of 90.1. So the Appendix G 2016, the baseline is essentially, more or less at 90.1 2004. So a great QC activity is to compare your baseline results to the 2004 prototype model for the same building type. And this tab does that for you. And it also compares your proposed design results to the next version of 90.1. So for the P4P program, if we're doing 2016 projects, it compares your proposed design results to ASHRAE 90.1 2019. So it's just a sanity check. If something is significantly different, it's just something to look into. Why is it different? Does this make sense? So again, this is just something to look at as a way to reduce review times, to prevent comments, keep things moving along. And then there is a quality control checks tab. And so for this tab, as a submitter, there'll be some auto flag checks. And I know this existed in the performance path calculator. The logic has been reworked for the compliance form. So we would like you to respond to any of the flags, auto-generated flags, before submitting to the program. And just note that, sometimes something can flag and you have a scenario, you have an explanation for it. For an example, your unmet load hours might be over 300, but maybe it applies to a 25 square foot closet or something like that. And so you can explain that on this tab. And we'll take a look at that tab shortly. And then there's the submittal checklist. So just so everyone knows, the submittal checklist was developed based on the reporting requirements of 90.1. And they're not exactly the same as the P4P program requirements. So this tab is great for just making sure that you don't forget something that's relevant, but just note that ultimately what's required to be submitted is dictated by the P4P program and is shown in the ERP. I've taken a snapshot of it here. So this shows what you're required to submit to the program. But the submittal checklist is a good tab because a lot of them align. There are just a couple things that don't. So it is a good tab to fill out. All right, we'll take a quick look at these tabs in the compliance form. So first we'll look at so our example here, we're using eQuest, and this is very similar to the performance path calculator, but you just copy and paste your PARMS file from eQuest onto this tab. Like I said, there are other software tools that are also supported now, so you can take advantage of those as well. Then on the compliance calcs tab, the unmet load hours will populate automatically from results from the BEM tool tab. You need to press the button to get these equations to update for your particular software tool, because this supports more than just a few now. So you just press that button if it's not populating. So table 1 is unmet load hours. Table 2 is very important. Again, you have the button to press if needed. So this table is similar to performance path calculator, but a little bit different. So we have a bunch of default end uses shown in white. You can add new end uses in these peach colored cells here. And then you can mark end uses as regulated or unregulated in this column, as that is very important for Appendix G. And this just reminded me, generally speaking, in the compliance form, we've talked about baseline and proposed. If you're doing a BEQ project, you only need to fill out the proposed sections. So that this just reminded me of that, but just something to note. And we hope to maybe do some training on BEQ to dive in a little more detail, but just a general note. Anyway, for Appendix G, you need to capture it as regulated or unregulated. And a very, very common mistake is for submitters not to separate unregulated end uses from regulated end uses. So here's a prime example. So the miscellaneous equipment for this example project auto-populated because it knows where to look for eQuest projects. And our miscellaneous equipment actually included elevators and escalators. But miscellaneous is all tagged as unregulated. But it included elevators and escalators, which is regulated. So it needs to be captured separately. So you can see my orange inputs here. And this is just where I extracted the elevator and escalator energy consumption from miscellaneous and captured it separately as is required by Appendix G. Okay. So then we have the energy costs. Press that button if it doesn't populate. And then all these other tables, no buttons or anything, but these are just helpers. Help QC your model, tells you savings by end use across different metrics. And down at the bottom here in table 7, it shows us our outcome. How well did our project perform? So it tells us because the program allows both cost and source energy, it shows them both. So we've got 22.4% savings for costs and 21.8% for source energy. So we're doing well. So you can see that here. And that's pretty much it on this tab. So then I'm going to move on to the energy performance summary tab. And we'll just look over this briefly. So it has what I described before. The top table is just a comparison straight of the baseline and proposed. Again, it's just, you can look there to see if anything's out of range, anything unexpected, anything crazy. Then tables 2 through 4 help identify the most impactful end uses in the project. And this helps reviewers know where to target the review. And again, helps modelers QC. Because if there's something unexpected, like, let's say space cooling is number 1 and you have no space cooling measures, you might question the results. And then below that, table 5 is where you choose the benchmarks that you want your project to be compared against. These auto-populate. So for Appendix G projects, the baseline is compared to 90.1 2004 prototype for the appropriate building type. And then because it's above code performance, it compares the proposed to the later, the next more strict later version of 90.1. So in this case, 90.1 2019. This is the first table looks at proposed across all these metrics. So across site, energy source, cost, and greenhouse gas emissions, it compares proposed with the benchmark. And it has this information in pie chart form. You can toggle between pie charts and bar graphs. And then lastly, you have the table that compares this information for the baseline and the benchmark. And you have the same tables. And then we've got quality control checks tab. So on this tab, you as the submitter, you want to respond to any checks that have been flagged. This table here, so anytime there's a flag that you respond to, it'll become yellow. So that if the reviewer sees this and there's all yellows and greens, they know, okay, this is good. But if there's a red, it means that there's a flag that wasn't responded to, and that won't be good. So respond to all checks, and this is the format. So basically all of the checks that we typically do as a reviewer have been integrated into the compliance form. So before there was just a handful, but now you can see all the different checks that are done. Not all automated, so just a few are automated. Others can't be because it's like looking at the design documents, stuff like that. So you'll want to, so if something fails, a comment will be generated, and then to the right of that can provide an explanation. So this one said, proposed pumping differs from the benchmark more than expected. And the response is, well, there are chillers, and that adds additional pumping energy due to the chilled water loop. So that's the tab you want to go through and respond to the checks. And then we've got this middle checklist. So I'm not going to go into this in too much detail because it's based on the requirements of 90.1, but it can be useful to point the reviewer to the location of different items. Okay, so let's jump to the compliance form. All right, so now we're going to go into the ERP and then hopefully have a few minutes left over for questions. So the steps for completing the ERP are: first, you want to import from the compliance form. So when you start to fill out the ERP, you basically have finished with your compliance form. So you're going to open the ERP, click import from compliance form, and then do that. So then number two, if you're using eQuest or Trace, you're going to copy the output reports on the results from and the hourly results tabs. There are detailed instructions on each of these tabs for you. Then you're going to fill out the measure info tab. So the program needs detailed information about the measures, like make, model numbers, capacities, stuff like that. So that information needs to be captured on the measure info tab. Then you're going to go to the P4P measure simulation tab, and we're going to look at this. This might be meaningless when you're not seeing it, but so then you're going to go to the P4P measure simulation tab, and you're going to make any necessary manual modifications to the simulation results, and we'll talk about that shortly. And if you used a tool that's not supported, this is where you're going to manually enter the results, the simulation tool results. And then lastly, you're going to go to the P4P project summary tab to review your performance and your incentive estimate. All right, so let's go to the ERP. So this is that instructions tab that I talked about. So the first thing you want to do before diving into your first project is just read through the instructions on this tab. So once you've completed your compliance form, you're going to click on this button, Import from Compliance Form, which I showed you in the PowerPoint. And for the sake of time, I'm not going to click on this because I've already done it. It takes like maybe a couple seconds to run. But basically, you click it, you navigate to your compliance form, and then it will pull all the information into the General Information tab. So for many of you, this will be very familiar. And you used to fill this out in the ERP, but now it'll just take the information, including utility rates, straight from the compliance form. So next, you're going to, like always, enter your results from eQuest. The compliance form does not require it to be by measure, so that's why you're entering it into the ERP, because you enter it by measure. And next, this is new, so I'm going to quickly demo entering this. So you're going to enter your hourly results. Either this is automated for eQuest or train trace, but I'm just going to show you very quickly how you would do it for eQuest. So there are detailed instructions on the website portal of how to generate, and here on the tab itself, how to generate these hourly reports. So I've generated this hourly report for the baseline from eQuest. And here's a productivity tip. If you want to select all this, just select across and select down. So I selected that and then hit Control-Shift down, and now I got it all. So you got all the information on this report generated by eQuest. And then you're just going to come onto this tab, click in cell A1, and then right-click and then copy. So you copy the baseline on the left, and then you do the same thing for the proposed right here on the right, and there are detailed instructions here. And this is so that the program can report KW savings as it needs to. And you saw I just entered the baseline report from eQuest, and on the measure simulation tab, now the baseline system peak has populated for me. So if I was really entering this project for submission, I would do that for the same exact thing, same exact report, everything for the proposed right here, and then it would populate my KW. So next we've got the measure info. I think a lot of you are familiar with this. This tab has not changed. So you need to capture the details associated with every measure for program documentation and quality assurance purposes. So you're going to fill that out as usual. All right, so next you're going to make any necessary manual modifications to measure simulation. This is really important and is a common mistake. So remember when we were looking at the compliance calculations tab in compliance form, and I discussed how it's really important to separate regulated elevator energy use from the unregulated miscellaneous? Well, it's the same thing on the measure simulation tab. So on this tab, anything that's been overridden highlights in bold red so that you remember you did it as a submitter and so that we know something's been changed. So it's handy. What I've done is the same thing I did on compliance calcs is because my results from eQuest grouped my elevator energy consumption with my miscellaneous, I had to extract it. So here you can see I've basically subtracted my elevator energy use from miscellaneous and then entered it separately so that it's correctly captured as a regulated end use. And so this is a common mistake with elevators, and we very often see it with refrigeration as well. So if you have a combination of regulated commercial refrigeration and unregulated, they need to be separated out on this tab to correctly calculate the performance for the building. And again, you just do it to avoid review comments and to expedite the review process. So once you've done that, then you can review your, so then you also need to fill out the changes made for each measure. You also, on this tab, you also need to fill out the changes made to the previous model run so that the reviewer can understand how the measures were modeled. What did you change in the model? And then after you've done all that, you can review the project performance. And these values here match what the compliance form told us. So we can see this as we make changes right in the compliance form itself. But once we're done, we'll want to import from the compliance form in order to see what our actual incentive payment, an estimate of our incentive payment. And that is captured on this tab as well as the tier. All right. So that is, let's make sure I covered everything. So let's go back to the PowerPoint. So we did the demo. All right, so we have a few minutes for questions. I'm going to pass it back to John.
Thanks, Christina. Thank you for that very thorough presentation. Okay, we do have a question from Daryl. How do you capture the WWR for buildings that have more than 4 sides in this form, e.g. the pentagon?
So that tab, the building, so there is some granularity allowed. So in the drop downs on this tab, there are options for north, northeast, east, southeast. So you just get as close as you can based on the granularity of these options. So it doesn't just have to be 4.
All right, so as Christina mentioned, we will have a copy of these slides here shortly, and we'll distribute them within the next couple of days. And the recording will also be posted on the New Jersey Clean Energy Learning Center. So we're also planning 2 more webinars in this series in the coming months, so please keep an eye out for emails with dates and registration information. And if you have any additional questions, reach out to myself or the outreach general email, and we will find you the right person to answer those questions if we can ourselves. And be sure to check out our website and subscribe to our listserv to stay up to date. And that's really all we have today. If there's any other questions, I'll check one more time. No, we are all set. So on behalf of New Jersey Clean Energy Program, thank you for attending today's webinar. I hope to see you in the next webinar in the series.
Thanks, everybody.